Can you hear me?
Oh, yeah.
Yeah, you can hear me? Good. Hi, everyone. This is Luke Johnson at Sol Crypto. We're doing the SolarCoin ElectriCChain open community hangout. I'm sorry, we just changed the link just in the last few moments. Sorry about that. It's the way the live stream works. So is everyone there? Could you please introduce yourself, or if you feel like it, and just let us know everyone's here. I'll just also check if the live stream's going. Hopefully the live stream is going.
Good morning, Luke. This is Nick Gogarty, SolarCoin Foundation, and everyone else.
Hi, Nick. How are you?
Fine.
Hope you're well.
Fine. Oh, I see you just put it into Telegram. Great.
So there's the new Hangout link. I put it in the live chat as well on the YouTube live stream.
You want to throw it in?
Telegram as well. Yeah, please share that link around so more people can jump on if they feel like it.
Right. Maybe in the Slack. Oh, yeah, it's in the Slack. That's why I'll put it in there.
Thanks very much. So we've
Good
got,
afternoon. Good morning.
Hi, Francois. How are you?
Good, thank you.
So we got Nick, Max, Francois, myself, and anyone else who wants to join. Please have a say hello, and we'll get on with the agenda, I think. So the first point on the agenda was just an update on what's going on the SolarCoin Raspberry Pi project. So I think that project's been going on now for over a year, I think, from memory. But it's been quite a okay project with many people working on that, especially everyone on the Telegram channel and other people as well. And I think the original objective of that project was actually to pretty much just put the SolarCoin wallet on a Raspberry Pi and just get it going. So I think that objective has been achieved. However, of course, it's a moving target, and the blockchain gets longer and longer with time. So we've always got to kind of maintain that as well. So if anyone else wants to have their opinion about how the project's going and how we would actually just fork that project into the next little projects that come out of it. So yes, please have a speak up. And so I'm not the only one just talking.
Yes. I can't say, Luke, that we are working on the update to BitCore still. So Joe Fasella is working on that primarily, and that will support the chain pruning. So maybe that'll help, and that'll be BitCore version 0.515.
Great.
So,
is that on the NPM repository? I think I saw a link for that a while back.
No, let me pull. I can pull up the repo for you. He's posting periodically as he does it. Just a second, but you can see where it's at. So and he says he's been having a few issues with the Genesis blocks, or getting the hash right. So I'm putting him in touch with various groups. He's going to help out. Let me just throw the link in. Where do I post the link for that?
You could probably put it in this chat or in Slack, or
there's
I think the live chat on the Google YouTube goes away at the end of the live broadcast. So I realized that actually last time.
So you can see last activity looks like it was 16 hours ago. Remove some binaries. So whatever
that's really great. And you think that there's probably a lot of complicated things that are going on there. So does he have an ETA, or he's not sure quite yet?
Not yet. I mean, he had an ETA 2 weeks ago of 2 weeks. It's classic software, right? We're 98% done until we're done. And for those of you who've written code or been on new projects, so doing that, and the goal is as soon, obviously, as he gets that pile up, that's going to be released for beta testing, and that'll be within the Qt wallets. And then the very next thing, once we have stable code up, and obviously love to have the Raspberry Pi team kick the tires on it and run around. A few things are supported with BitCore that are important to the foundation. Obviously, chain pruning, a more stable code base, one of the killer features in there is full support for time lock. So we'll be time locking a lot of the Genesis pool. So hopefully that alleviates some of the concerns around the large pre-mine. So that'll be going on. So we're going to come up with a design for the time lock mechanism. Obviously need to research that, test it out quite a bit. And then the next thing after that immediately to develop is copay. So once we have the core there, copay is copay.io, for those of you who don't know about it, is a very nice lightweight SPV wallet, simplified payment verification wallet. And the goal behind that is to make it a lot easier for the average person to sign on. Because right now, downloading a full version of the, running a full node is pretty heavy for your average person in terms of resource time and just, pure pain and ease of use. So that's what's going on the client side. I can talk about some of the other stuff going on under the hood, Deb, but that was your first question, so I'll leave it at that, Luke.
Okay, yeah, no, it's really amazing. Great work there. All excited. So maybe we'll put them at the last part after the anything else agenda. I noticed that Francois also has another point to add there about the Solar Power Europe report. So we'll just put that at the end as well. But I don't want to stop anyone talking. But I'm just going through the agenda.
Sure.
Yeah. So once we get the SolarCoin Raspberry Pi project going and it's quite stable with probably the copay wallets pointing to that Raspberry Pi projects, they'll probably split off into other projects, I'm guessing. So there might be, it'll go off into a few different projects there, and then we got to kind of see which ones those are so that people can kind of work on those and source and so on and so forth. But what does everyone think? What do you think, Nick, about that?
I mean, personally, I'm very excited about it because I think what looks to be a small project is a very, very important proof of concept, and it's very easy for a lot of people to say, hey, you just put that on a chain and it goes. But I think it's a huge proof of concept, and we will be presenting that with Steve and others to a couple of large inverter manufacturers and using it as that proof of concept. And also, it's not just the hardware integration, but coming up with, attempted a first standard for the reporting on a chain, the design of the security, it's evolved from that. Again, kudos to Steve and yourself, Luke, and others who contributed. Watch the Telegram channels, and it's very cool. It seems like a simple thing, but truth and integrity at the edges of the network for transactions is a hugely important foundational building block to eventually what will be, and I'm going to borrow a phrase from some other people in the space, but the transactive grid, right? Where nodes are actually buying and selling electricity. But first you have to have trust in those nodes before they can transact, both their production, consumption, and purchasing. So, and I've given reports. Yeah, I mean, I've given reports and analysis to the vice chair of large Chaebol, a very large. I was on the phone with the CEO of a $20 billion energy company on Sunday, talking about SolarCoin. They're looking at filing some claims and getting to that later. But some of these people we talked to, the vision that I'm explaining is the future is going to end up having an energy grid that is very different from today. And the model I give for today's energy grid is it's literally like the mainframe model with dumb terminals, where you have central repository that literally just broadcasts out to fixed endpoints. And the future is going to be distributed and mobile. I was in DC last week talking to a room that had senior officials from the IMF and ex-secretary of the U.S. Treasury and some other fairly heavyweight folks, and I was mentioning it's like the energy revolution that's going to happen with cheap solar and cheap storage especially, which is seriously underestimated. The woman who was heading up, I met the head of S&P infrastructure. She gets it on storage. Storage has dropped from 700, and it's approaching $100 per kilowatt hour. You're going to have electric vehicles, running around buying and selling electricity. Every node is going to optimize its consumption and production in conjunction with its storage capacity. And so, one of the biggest energy players in the future may be Uber or Lyft, because they'll be massive consumers of energy. And that stuff sounds far out, but it's not. It's 5 to 7 years. The numbers from Bloomberg, which I think are probably going to be underestimated, are that there'll be 230 gigawatt hours of storage shipped in 2022. And 230
really
gigawatt hours. Yeah, that's a huge. I mean, that's a to use technical terms, that's a shitload of storage. And that that figure comes from Bloomberg New Energy Finance. If anyone wants to look it up, it's BNEF is the source. And something a lot of people don't know about car batteries and EVs is those EVs after like 6 or 7 years, those batteries aren't as effective because it can't meet the high drainage requirements, right? So if an EV needs rapid acceleration, it needs rapid discharge and charge. Batteries are no longer functional at that capacity. They can be repurposed and literally thrown onto the wall as power storage. So you're going to see massive amounts of recycling of these batteries, whether they're either totally remanufactured and refreshed, which is very expensive, or just repurposed. And that's a revolution. I mean, imagine hundreds of gigawatts of storage coming online. That's just massive. And the third piece to the puzzle, when I usually tell people what I think the energy revolution looks like, there are 3 pieces. One is solar, which we all kind of get in terms of its cheapening. The second one is storage, where the market hasn't really realized what that means because storage hasn't hit in huge orders of magnitude. And the third one is blockchain, because that's what's going to allow the transaction element with millions of mobile nodes acting autonomously to buy and sell electrons.
That's really good. Let's introduce as well. There's the Solar Pi team. I noticed that I've joined. Thanks, guys, Dom and Ilya and everyone. So maybe we can introduce you guys too. Like it's the first time you've been on this chat. So
and explain who they are. Congratulations to those guys out in Bangkok.
Yeah, big congratulations. Yeah. So if you guys want to have a little bit of chat, what's going on, that would be really nice too. Maybe in a few minutes after we talk about blockchain grid edge, because I noticed the next point was more about Steve and I were talking pretty much this week about know your device, know your object, integrating different identity protocols, either open source or specific protocols with grid edges,
right?
And your nodes, because you've got to look at it from the attack vector scenarios.
Right.
And if your building blocks are not solid, you're not going to have a building block in terms of an engineering point of view. So we were just discussing, a few different chips that you could use for your elliptic curve chips. For example, the ECDSA chip or the new one, the EdDSA chip. But we're kind of going to the limits of what our expertise is here. So we'd really like to either work with other people who are quite...
To be honest, Luke, beyond my limits.
Yeah, work with other people who are specialists in these chips, and either full security reviews of the chips, because I even looked into some of the standards for the certification of the ECDSA chip, and found out that the certification body, a few different researchers were saying that body, they can't exactly mathematically prove that their body's okay, so they'd like to do a different way. So I'm at the limits of what I can comment myself. So that's something that we'd like to talk about a bit more if anyone else wants to add in their opinions about it as well. I think it's a great thing to look at, over the next few months as well.
I mean, for me, Luke, my kind of personal thing is I think if we can get something that's pretty solid. I mean, I'm no expert in cryptography at all. I'm very far from it, and the math is way beyond me. But I mean, I think ECDSA is actually fairly secure. So I was saying to you on the chat, as long as you've got a really good source of entropy, and you're using something which is not repeatable, and I pointed you to, it's just on Wikipedia. Sony lost their security because they didn't recycle their keys properly, and they were using the same source for all of their entropy, and so it was revealed. And I think from what I understand, ECDSA is insecure if it's not implemented properly. I think it's one of those things where it's kind of got a bad rap because people don't implement it right, and then it fails. I think it's one of those things, if you implement it well, then it's probably still secure. I don't know anything about EdDSA really, but again, it's probably going to come down to the devil being in the detail again.
Right. That's what I'm a little bit concerned about.
Expertise beyond mine, understanding what's the proper and secure way for implementation.
So can you talk a little bit through what you've done recently, Steve, with the concatenation between, for example, the serial number of of a chip and, for example, a private key that you can generate on the Raspberry Pi, and putting them together and making a new proof hash or things like that. That's something that is really great that you did recently.
So I've got a functional data logger for a while now that can look at my solar PV system, ping it for data, poll it for data on a regular basis, and we can set some limits about whenever it's produced X amount of energy, create a transaction through the SolarCoin wallet and post that into the blockchain. And then the other key problem to that was, well, that's wonderful, but how do you actually systematically read the data? So I did the other end, and I've figured out a couple of different ways now how to actually scrape the blockchain and extract the data on the other end. So maybe you can do some graphs, or basically you've built an SQL database. If you're good at doing database queries, I'm sure you can kind of do all kinds of things with the data. But the problem with all of that was, anybody could just go into their SolarCoin Qt wallet and start writing messages into the blockchain, and there'd be no way to know whether that message came from a real data logger or just some guy tapping it in on his terminal. So I started looking at what we could do to somehow authenticate that. At least the first step was at least that the data logger or the SolarCoin wallet that was hosting the message actually was real and was the one that was connected to the inverter. So I scratched my head a while on that, but then I realized that inside all Bitcoin type blockchain protocols, there's proof of identity already, which is the digital signature. So what I did is I started using the digital signature itself. So you take an address from one of your own wallet, and you write a message, and that gives you, and the wallet can give you a digital signature which is unique to your address and unique to that specific message. And if I give that message and that address and that signature to any other party anywhere in the world, they can reverse that and say, actually, yes, it was an address from Steve's wallet, which actually did write that message with that signature. The cool part is no other wallet except for mine can write that message with that signature. So someone could try and copy the message and say, try and post that message from their wallet, but then the signature wouldn't be valid. And so we then get some kind of provenance that the message that was written by my data logger was actually written by my wallet. So that's kind of step one in kind of saying, well, we absolutely know that Steve's wallet did that. Now, the next piece to that is, well, you're going to try and make a chain of data logs of different energy. So what we want to do is make sure that each data log of energy is signed from the same address. So then we can be certain that somebody isn't trying to jump in the middle of my data login history and try and insert a false one. So as long as we always sign from the same wallet address, we can always go back and check that anyone in the world can go back and check that those data logs came from that same wallet.
Okay, and then you just, sorry to jump in, but that's amazing. That's really amazing. Very impressive. And then basically, anyone can go and check that on the blockchain, right? You've written
Absolutely.
another Explorer, like I think you call it sunfinder.py Python file.
Yeah, so basically the piece to extract the data from the chain, what I've actually done is I've written basically it's almost like a custom blockchain explorer. And what it does, it just goes through the blockchain and searches for data login entries. So it looks at every single block, looks at every single transaction, and if the syntax of the message that's been written into the blockchain is in the correct form, it decodes it. And then what it does is it says, right, and in that message is the energy that I've produced and the signature. And it says, right, I've got the message, which is the energy, and I've got the signature. And, you know, so I can go back to Steve's address and check that that message matches that signature and it decodes properly with the hash. And it's quite actually easy to do this. I don't know if people want me to share my screen very quickly. I won't delve into it too much.
Yeah, have a go. That's really good. Just for a few minutes, yeah.
I don't know. I'm not very good with screen sharing. Can you guys see my screen?
Yep.
Okay, cool. So I've got a SolarCoin, my SolarCoin wallet here on my Windows desktop. If I just go to File, Sign and Verify Message. So basically, this is basically how it works. You type in a message from one of your SolarCoin addresses. Say, and you sign it. And then it gives you this long signature down here. And so now if I give that exact same message to anybody else on the network with that signature, and they know it came from that specific address there, and we can go to this verify message function. We'll just copy that. And you see we get a nice message verified. If I change anything about the message, if I put a full stop in, the message does not get verified, it fails. If I try and change the signature slightly, the message fails. If I try and sign this against, let me just go in and find any I'm just going to go and grab any address off of the blockchain explorer. If I try and sign the message from a different address, then that address isn't in my address book on my wallet, so it doesn't work. So as you can see, it's very difficult to actually falsify data logs or anything else if you don't have the rights to do it.
So you've replicated basically those steps in the Python code.
Correct.
Yeah, in Sunfinder.
So basically, I've just there's RPC, like every wallet has an RPC, a remote procedure call, which is basically some messages you can send to the wallet to tell it to take certain actions. So what I've said is like take an address from your wallet. Here's a message. Go in and do a digital signature and put that into a transaction which you post to the blockchain. And then in the Sunfinder on the other end, when it's going through searching for messages, I'm saying, okay, extract the message, break it into its component pieces, one piece being the energy and the other piece being the signature. And there's a special log which happens the first time you data log anything, which actually gives you that address. Go back and find the right address for Steve's data logger ID and then decode the message. And if it decodes properly, then you know that Steve posted it. If it doesn't decode properly, it's trash, just ignore it. So that's the basic piece. The next level is I've actually done a hash on the data logger program itself to say, has anybody actually tampered with the program? And that hash is also concatenated with the message. And then I've done another thing where the data logger actually goes off and looks at the serial number of the inverter that it's talking to, and that's also hashed into the message. Great. So it starts to get really hard to start finding a way to defeat the system. I mean, it's not impossible. I mean, I'm not really an expert coder, but there would be ways you could defeat it. But in a sense, my approach so far is make it hard enough that it's really, you know, it's going to be beyond your average user. You're going to have to be someone that's really going to dig in, being prepared to dig into this stuff and start falsifying it. And remember, this is with no third-party trust or anything, right? So if, for example, we had a way to register user IDs with a central party, maybe an affiliate, then that would really start to make this super robust.
Yeah, that's something else that BlockPass is working on. So there's a KYC procedure and also a KYD procedure when you log into an account, for example, on an affiliate level. So we're trying to make it like a building block so it plugs into it. But, you know, we'll make it in a way that, you know, any one of those services could plug into this just to bring that extra level in, as you mentioned. But that's really great, Steve. Yeah, if you want to talk about anything else, we could probably move on and talk to the SolarPi team.
Yeah, go for it. I mean, that's pretty much a 5-minute on what I've been doing. So, you know, the last thing to say is we've got 2 different routes now that you can actually scrape data from the chain. One of them relies on the chain's API from the chain's website, SolarCoin Block Explorer. And the other one now is actually one that runs directly just on the local machine. The problem with the chain's approach was there's a single point of failure there. If chains got DDoS, then you wouldn't be able to extract any data from the blockchain. But I've now got a localized Python block explorer which can actually read the blockchain directly from your local machine. So there's, you know, you've got 2 options now. So
I think we were discussing that this week, and you thought you're going to go with the fastest one first, or you're going to have a backup one, or what did you end up doing there?
I haven't got to the point. I mean, the databases that they build, the local database is exactly the same, but they do function in quite different ways, and I haven't quite got to the point of deciding if I can integrate them into like one tool which will decide which is best. The chains is faster because chains do a lot of heavy lifting. They go through the whole blockchain, search for all the messages, and just deliver you messages that are actually ready to be decoded. If you run the localized block explorer, basically you just have to search through every block and every transaction and find them, so it's a lot slower. But I do actually feel that even though it's slower, the newer one, the one that actually searches on the local machine, is more robust and more reliable, and we've got more control over the data we pull out of the chain, and it will allow us more opportunities for upgrades in the future. The problem with chains is, you know, I have to ask the owner and admin of the chain's website to make changes, and he's been really great, by the way, fantastic guy, but in the end he's published an API and we can use it, whereas using the local version, you know, we can do whatever we want with it. So if we want a protocol change or version changes, we can easily write that into our local version, whereas asking a third party to change their API is a lot harder.
Exactly.
So my real preference would be, you know, chains was like to get us through proof of concept to show that we can do it. For me personally, now using the localized version is the more robust and future-proof method.
Okay. No, it's really great work, Steve. Kudos there. So I think we can move on to the next thing. So does Dom or Ilya or anyone else from the SolarPi team want to have a little bit of a chat, or just say hello, see how you guys are going? Is anyone there? Hey, Dom?
Yeah, hi, here, Ilya.
Yeah, so just how are you guys going? We noticed some really good messages this week from what you are talking about your status of the project. So maybe just give us a little bit of a rundown, how you guys going, and what do you think you can achieve as well in that area?
Yes, so we made kind of proof of concept solution with writing the data, securing the data, writing it. Mostly it was DOM solution, but yes, so we are thinking about the particular wider scale implementation of it, which will help us bring more installations. And it seems like we need to implement it probably not on the IoT side, but to integrate it with inverters. And we just wanted to get more feedback on particular particular more effective ways to do it.
Okay, yeah. So you wanted to get the code shipped to inverters, plus probably a proof of concept with the Raspberry Pi or a similar IoT device. What do you think there, Nick, as well about this? It's a good concept to just ship the code to inverters as well.
Sorry again.
Yeah. So just asking about what Nick is Nick there as well? Maybe he's not there.
I'm here.
Oh yeah. Yeah, Ilya was just mentioning he wants to ship some of the code to inverters as well, because we were talking to a few different inverter makers beforehand. Yeah.
Yeah, if you guys want, I mean, I can pass along messages or whatever to, I tried to reach out to Enphase, right, their CEO and a few other people, and then they just kind of dropped it. But I could pass a message along to SMA. So if you guys want, I can put you in touch with someone there.
Yeah, thanks. That will help. Yeah, we just actually just finished the proof of concept paper today. I guess we'll send it to you like after this chat.
Okay.
Yeah, so we just need to communicate with the inverter manufacturers a bit more, and yeah, to find some effective solutions. That's it. From the like proof of concept point of view and the work we've done with securing the data and writing it to blockchain or foundation API. Yeah, that's probably Dom can say more.
Okay.
Yes,
Yeah.
can you hear me?
Yep, that's great.
Okay. Yeah, so I did a lot of research on the cryptography sites, and yeah.
Hello?
Hello? Maybe get everyone to mute a bit. Yeah.
Yeah, I've got some noise also here.
Yeah, it probably just dropped out a bit.
Can you hear me?
Try and mute if you can. I'll mute as well.
Okay. Hello, hello.
That's better.
Ah, okay. Yeah, there's a problem. Okay, I leave it like this. So I've done some cryptography research in the last few weeks, and yeah, finished this.
Maybe switch it back to how it was just before, because it's not reading or something. Maybe you move the microphone or.
Yeah, it adjusts automatically. Better now?
Yeah, that's better.
Yeah, so I keep the mouse on it. Okay,
Right.
so I was thinking about a attack scenario where the attacker would be the operator of the PV system, because this would also be a possible attack on the system, right? If someone wants to double his output, for example. So we are not trying to ship code to the inverters. We just want to ask them to provide an option to read the data signed by a private key of the inverter, for example. So it would be really awesome if they could implement private keys and public keys into their inverters. This would mean that the solution is probably like 1 kilobyte maximum from the storage point of view. Versus, yeah, if we put code into the inverters, they would have to trust us, etc., etc. They would need to be able to run our code. So probably for each manufacturer, it would be different. So we try to we just want to ask them to encrypt their data, because then we could be sure it's coming from an inverter. If they provide a certificate signed from the manufacturer's main private key. I don't know if you are into this stuff, but the paper explains it a little bit. We will share it afterwards. So the manufacturer could basically issue certificates of trust to their inverters, which they would, of course, do because they produce them. And now when the inverter is asked for data, it can provide the certificate, which can be, yeah, so we can track it. We can track it back to the manufacturer's public key, basically. So then we know it's an authorized inverter we're talking to. And if the inverter now encrypts his data, then we could extract the data and we know it's, for example, an SMA inverter with valid data on it. So it's not like we try to ship code.
So that's similar to maybe a know your device proof hash when your inverter is born, right? For example, you got a production line, you're making an inverter, you got all the parts, right? Then if you got all the 5 or 6 main chips, and then you proof hash them together when you put them together, and you produce a public-private key pair, and you call it like your birth certificate, basically, of your inverter. Is that what you're kind of getting at? Or
something like this, but I think it could also be like updated. I don't know if there's an inverter that is automatically updated, they would probably also be able to perform this securely. So it's not that hard to
yeah, because that original birth certificate process has got to be pretty locked down the moment it happens, right? And then you afterwards, updating it might be more difficult. That's what you're saying.
Yeah, that's definitely one of the value adds for a manufacturer, right? Where they just bake it into the hardware at birth and lock it.
So for
yeah.
them, it would be a lot of additional effort. And I'm not sure. Maybe they already have a similar thing just to update the device. I don't know. So maybe they already have certificate stuff like this on there.
Yeah, we were looking into it as well with Chain of Things. With basically when we're producing they call it like a blockchain birth service. So it's like a third-party service that comes in, or either trains the manufacturer to do it, or the manufacturer actually just adopts that service or that way to do it. But yeah, there's something there that could definitely be of value added when the actual equipment is made.
Again, it kind of brings us back to just making sure it's implemented properly, Luke. And like if they just don't cycle the same keys and stuff like that. But as long as that's done, actually, Dom, it sounds like a really good solution that you can trust the data from the inverter. Then,
yeah, please go ahead. Sorry we cut you off.
Yeah, so I mean, our paper is we want to present it to you, so you can see that we put effort into the security stuff. So you can ask us anything about it. We made it quite bulletproof. I mean, the implementation is something else, but the concept is I think it's quite fine until now. And later we want to present it to inverter manufacturers as well, so they can understand how easy it would be for them to participate in the whole SolarCoin network. And get their inverters ready for it. So they would have sales, another marketing argument for their product, and so on and so on. So
value added, yeah. And then they can work with the SunFinder scrapers of the blockchain, macroscope projects, all of that. But it's just getting these first blocks, you know, the solid engineering blocks done properly at the start, right? And I think you're really onto something there, everyone here on this channel. So kudos to everyone. And
yeah, and Dom, from our side, and also Stephen, we have a number of venues where we're meeting some solar experts as well. Mostly, and probably the main one is going to be in later on in December in Munich on December 4th evening and 5th the day at the BMW Center. They have a solar in digital storage. And so we're attending there. So obviously, I mean, if you want us to reach out to these inverter manufacturers, those with which we're not yet in contact, because we have some contacts then we could present a solution. I mean, the different points of such a solution. That's awesome. Yeah.
Yeah, we could. I mean, it's still almost. Yeah, it's still almost 6 weeks until then. So I think we can prepare something for them that you can show them.
Sure.
From my side, Francois, you know, I've got working proof of concept already. I think what we just don't want to do is confuse manufacturers with too many like different options. You know, I think Dom and Ilya and co have been doing a great job. If you know, whichever way, I think we just need to probably come to like a unified experience. Dom and Ilya,
exactly.
can I just ask you? I mean, is the focus of your system actually granting SolarCoins, or is it recording data, generation data into the blockchain, or both?
We try to increase adoption. So if this means that we we have to write data to the blockchain, then we would do it. But yeah, we know it doesn't work this way. So writing data to the blockchain is not our main goal. We want to kind of act as a intermediary to help users and inverter manufacturers to integrate SolarCoin into their system/inverters.
Okay, that's what I thought, Dom. And so in effect, really, you're working on something slightly different to what I've been doing, which is cool actually, because now we have two different things. So mine is really focused on how do we take energy data and put it into the blockchain so everybody can, in an anonymous way, so that everybody can see it. So, you know, I think that's a slightly different goal from what you guys have been working on, which I'm pleased about actually, because it means we're not overlapping. So I think then it would be, as long as we're clear about what we've been developing, then it's okay to present both or either to a manufacturer, right? I just don't want it to become confused, you know.
Yeah, sure. But we both need to make sure that the data is valid. This would be something we both need. So we want the exact amount of power generated, so we know how many coins the user would get, and you want the exact data, right?
Yeah, exactly. No, and I think your solution that you just spoke about, Dom, is fantastic in terms of digitally signing it from the inverter itself. I think that's a really cool innovation. So, but I didn't want us. We're not trying to do the same thing, which is nice. So.
Yeah, it's really good. It's like we're making a rainforest here of IoT projects on the SolarCoin and other blockchains, right? Because the focus of ElectriCChain is blockchain agnostic, right? So we're open to using different blockchains as well, trying to make the protocol interactable between, is that a word? No, it's not, but interactive between different chains.
It is now.
Yeah, I've just made it a word, but there's different chains coming up that we're also researching too, like the EOS chains that they're not even in production yet, but there's some interesting chains coming up as well that we'd like to connect SolarCoin with these different chains, but it's one step at a time. You know, we just got to look at our feet, which is getting it solid on the data logger level.
Yeah, what do you think of ways to connect the SolarCoin with web chains? Yeah, how do you see it? Just curious.
Yeah, at the so Steve and I have been working on the ElectriCC protocol, which is basically the JSON format that fits in the little text message space. Right on the, whenever you do a SolarCoin transaction, there's that little 512, or is it 523 characters
Correct.
of space that you can use. So we just thought, you know, probably a while back, last year or something, we thought we'd better make it organized there, just make it into a kind of syntax. So, and then Steve had a great idea to JSONify it, basically make it into a JSON format. And once that's happened, that allows it to be at the abstraction level, which is a bit higher, so you can interact between Python and different languages. And once you get to that level, you can go and hook into different chains as well. I mean, there is a problem with tempo as well, because the SolarCoin blockchain is every minute. But these tempo problems can definitely be sorted out with concatenation or summary hashes or things like that. But there's definitely ways to interact with different chains at that abstraction level or in that character space.
Okay. Yeah, I think I get it.
Yeah, please stop me if I'm off, but hopefully that's the idea, is using the JSON little package format.
Do you want to just throw an example on screen, Luke, so people can see it?
Yes, I'll share my screen here. See if I can find it. Oh no, it's no good.
I've got it on the Chains Explorer here if you want to just
maybe
share
try yours. Yep.
So I don't know if you guys can see that, but
that's
in the message space there, that's the JSON portion, which we can then, you know, it's got the user ID, and then it's got time 0 and the date and time, and then megawatt hour 0, and you know the different, you know, all the different readings, and then concatenated on the end is the signature there, which was what I was talking about earlier, which proves this was signed by, you know, the correct wallet. But basically, so that's what Luke and I, as he said, has been working on. This is we've got 2 data logs actually. One is for generation data like this, and one is for system data. So the first log is system data, and then sub logs are basically then the generation data.
Do you have an example of the other log as well, so we can just put it up?
Hopefully I can find one quickly. If I just search on this user ID, should be able to find one. Yeah, here's the system one. So the leading sysv1 or genv1 tells us whether it's a system or generation log, and then basically you can see the same user ID here, and that's the signature address I was talking about earlier. That's the address that all the different data logs are hashed against, and then signed against. And then we've got, you know, this one's just a test one, so we've got module test, inverter test, but these are all basically all the different fields that we have in the standard that Luke's been putting together that we can post into the blockchain.
Yeah, sorry, I talked and now it's switched the screen, but the idea to make that standard there was looking at it, if you're trying to prove the generation of kilowatt hours from that system, if you have a few important pieces of data, and those few bits of data is the latitude, the longitude, your tilt angle, the size of your system, and a few different other parts, you can basically write a little program that can actually predict the energy coming out of that system to a certain degree of certainty, depending on your microclimates as well. But there's little programs that could basically live and scrape those little messages as well. That's why we're trying to build it in that way. I'm trying to think a bit ahead there, but we're not up to that yet.
Yeah, okay, get it. So you want to use it to like practically probably verify the generation data with yeah, based on analysis of that scraped data.
Yeah, that's right. So I've been playing around with that probably the last year or so, and it's come to a point where we can say, you know, within 8 to 9% certainty, depending on the time of year as well. But over a yearly average, we can pretty much get into about 9% uncertainty. I think on an uncertainty budget type B uncertainty budget, but yeah, it is quite a difficult thing to do, and it depends also on your irradiance data and your little microclimates and things like that. But that's something that, yeah, we're trying to work towards as well.
I think, Luke, we've talked before about if you've got local peers, in terms of, you know, we've got latitude and longitude in there, you can kind of start tying together different sets of data in a local area, and start seeing, like, you know, if there's trends or outliers and stuff like that, which, you know.
Yeah, that's a really good point. Yeah, the kind of like local cross-checking of each other. I think that's another step down the line as well, but getting to the critical mass is important as well. And sometimes the systems themselves have peculiarities. You know, they've got a shading profile that you didn't know about, or other things like that. But definitely, if you have more of a critical mass of a data set and a good scraper, you'll be able to pick out those points eventually.
Yeah, and I can tell you on my system, for example, I get one result if I query the inverter on my local area network. I get a different result if I go to the manufacturer's website, and if I look at my actual generation meter, I get a third result. So
Yeah,
even on one system, it's like there's a spread. So, you know, which of those numbers is closest to the truth? Well, it's impossible to know, but you know, that's kind of reality that you're dealing with. But in terms of dealing with large data sets and everything, the spread is fairly minimal. I haven't actually measured it, but it's not large. I'm just saying there's all, depending on how you do the measurement algorithm, which is probably going to vary between manufacturers, you're going to get slightly different outputs anyway.
Yeah. Okay. Well, that's probably can win. I want to talk to Max if he's there as well, just to say hello and see how those guys are going at Solarly as well, because I noticed, is Max there? But I noticed you guys did some great things this week as well.
Yes, hello. Well, first of all, I would like to say
hello,
that. Yeah. Can you hear me? It's okay.
Yeah. Yeah.
Okay.
Yeah,
Okay. Okay. So yeah. So first, I'd like to thanks every people on the Telegram, Stevens, Dom, and you also, Luke, and to for the nice improvement about the Solar the Pi, SolarCoin Pi, and well, we continue. So, about should I talk about Solarly or something, or sorry.
Maybe if you want to, or if you want to just have any comments, is what we've talked about today as well.
Okay. Yes.
Any other additional comments?
Yes.
Yeah.
For sure, there is the two case of scenario where people in the futures can use the SolarCoin and claim the SolarCoin with a Raspberry Pi or a third-party device that's aggregated by SolarCoin Foundation, and this is what Steven is working on it right now to push the people to claim SolarCoin and to use SolarCoin at home. And also the possibility to embed the SolarCoin ecosystem directly into inverter manufacturer. So I think these two visions is very interesting, because and about the second one, I think it's going to be a bit more secure, because when the system is included in the hardware of the manufacturer, it's harder to get the private key, to get inside the thing, and then to hack. It's more difficult than to hack a third-party device. But this is why maybe in the futures we have to move maybe to outside of Raspberry Pi community, because everybody know how it's work Raspberry Pi. I mean, the documentation is very open. So my concern is to use maybe another hardware that is really look like a black box, so nobody really know how to go inside. And
I had a similar conversation with a guy as well. He said reduce your attack surface. So he's like, yeah, use your own operating system, which is a lot harder. Yeah.
Exactly. So, but also this vision is compromised by the fact that we want to put this thing into an open source architecture. So it's quite hard to find the good points between full open source and also non-open source, because we want to secure the device, the third-party device. And yes, I think there is a lot of challenge in this vision. And but it's feasible, and I can't wait to see the improvements and to also to start to work on this different thing, even if I wasn't really active this last week. That I'm really looking forward to join more the community and during the next future months.
That's great. Yeah, thanks for the summary there, Max, and thanks everyone. I think we're coming up to the hour, so if there's any other things that Francois want to talk about, or anyone else, Nick, just to wind up maybe another few minutes.
Yeah, sure. I mean, from our side, it's very simple. I would say that we continue on business development, and obviously the hard point being to making understand people around that SolarCoin is an open blockchain and that it works for any solar company inside the value chain. But that's going on well, especially since the launch of the digital and solar report by the Solar Power Europe team. So that's really had a good impact, and as a matter of fact, they're going to redesign the report and extend it with more use cases and relaunch it as a well, how would I say, a higher title report.
Can you just fill us in a little bit about that report, Francois? Because I think it's a very important report, the Digital Solar Europe report. Yeah.
Sure. So Solar Power Europe is the European Solar Association, and to which, with ElectriCChain, we represent the SolarCoin Foundation on the board, but sorry, in participating to the digital task force, which has been set up. Now, the digital task force has made 7 recommendations for regulatory changes at EU level, and so the European Union is also looking at developing, well, is looking into those 7 points and at developing specific legislation about that. One of them is incentives for the solar energy. That's where SolarCoin might fit in, of course. But other ones are peer-to-peer, how would I say, regulatory objectives. And then there's another number of regulatory points which have been discussed within the digital task force as well. And so in essence, one of the works from the task force has been to launching this digital and solar report, so as to make available, I would say, information about different business models in the digital sector and specific to solar energy. So there's, well, obviously virtual power plants, peer-to-peer energy trading, SolarCoin incentives, but there's also monitoring platforms participating and explaining on different developments that they have achieved in, well, with their works. So that's been an important document to assessing the position of SolarCoin, and perhaps to putting SolarCoin at the forefront for business development. And it was launched at the European Utility Week just recently in Amsterdam. So well, from our side, we took part to a panel discussion with Irina. So we also launched that report. We met with EdDSA from Grid Singularity, LO3 Energy, and all those guys over there. So that was a good event, high impact event. We also happened to meet with the Energy Web Foundation guys. They're looking obviously at SolarCoin as an add-on tool to what it is that they're doing. So most of these companies are doing peer-to-peer energy applications or microgrids, and so they see SolarCoin as a useful tool in that regards.
Okay.
And yeah, sorry. That's about it for us, I believe. Yeah.
So what do you think, Francois? Just one last question before we wind up. So what do you think as the price of solar energy continues to drop, right? It's been dropping at a historically, I don't know, it's like 30% cheaper every year, but it's different in hundreds of markets all around the world. Like the actual price to generate your electricity is very dependent on your supply chain and all these other things. But it continues to drop and drop and drop. So eventually we're going to get down to below a threshold level, which could be near zero. I don't know, probably 2 or 3 cents, maybe 4 cents a kilowatt hour. Do you think there's going to be a price of the solar coin as well is going to actually increase over time as there's going to be more people in the network, according to Metcalfe's law? So these two things are happening, right, in different trends. So what do you think is kind of a 10-year out horizon on those two trends?
Well, my understanding is that because the price of energy is going down. I mean, you could see in Dubai, for example, the new power plants being installed or developed. They're pretty big, obviously, so they can afford a lower price, but they've been quoting below $20 per megawatt hour. So that means that, well, I wouldn't pronounce myself on the return on investment of such a project, but it does mean that the energy is getting very cheap. The good point is that it's going to become abundant. So in relation to that, one way of valorizing it or making value out of it is probably going to be through SolarCoin.
Right. Yeah. What I'm trying to get at is right now there's a big distinction between the transaction rail, which is paying for every kilowatt hour of electricity that you're buying or producing, and the rewards rail, which like SolarCoin is sitting on top of. So at some point in time, there's going to be kind of a merging of those rails, but I'm not really sure when, and it's probably very complicated. So it's something I wanted to talk with everyone about and get their opinions as well, because it's probably a while away, but something very interesting happening there.
Well, we see SolarCoin more as a tool to incentivize. So at the production or the generation level, probably you might be giving another value to the coin for the use of it or the use in time of the energy which you're using. So the moment at which you're actually feeding it into the grid.
Yeah, at some point in time, it's going to be hard to differentiate between those, right? Maybe I'm completely off, but something I was thinking about early this year, late last year. So if anyone else wants to chat about that, please give me a call. But yeah, thanks everyone. I think that's pretty much winding it up. If anyone wants to have any other comments, please let me know. Yeah, it's been a great talk.
Thank you for organizing, Luke.
No problem.
And thank you all for attending as well, for joining on the call today.
It's really good. I think we got about 10 people here, and we've got live chat, people saying hello. So a really good talk today. Thanks everyone.
Great, thank you very much.
Yeah, thank you for hosting.
One question. Max said someone else is working on the same problem as we are. Steve or someone.
Yeah, no, I think, no, he was referring to me earlier. So no, we're working on slightly different things.
Okay.
I think they're easily conflated, but they are different.
Yeah. Okay, got it. Yeah.
But yeah, please take conversations, keep going along. Keep going. The sun is within you.
Okay, thank you.
Have a great weekend.
Have a great weekend.
Thank you.
Bye.
Bye-bye. Bye-bye.
Bye.